Hello, and welcome back to the Strange Water podcast. Thank you so much for joining us for this week's episode. Today, we are speaking with Alex Pruden, Executive Director of the Aleo Foundation. Aleo is a privacy-focused Layer 1 blockchain. Using the magic of zero-knowledge cryptography, users are able to interact with the Aleo L1 completely privately, while still maintaining all of the benefits of blockchain, like permissionlessness and verifiability. But Aleo is not just a general purpose L1. It comes with an embedded prover network, which is something that you'll quickly discover has massive implications for the entire ZK ecosystem. During this conversation, we dive deep into understanding how Aleo works and how ZK completely transformed both crypto and really the broader internet. This conversation has something for everyone, from the economics of ZK proving to the viability of all L1s to the applications enabled by these new paradigms. One more thing before we begin, please do not take financial advice from this or any podcast. Ethereum will change the world one day, but you can easily lose all of your money between now and then. Okay, time to start the show. Alex, thank you so much for joining us on the Strange Water podcast.
Yeah, it's awesome to be here. Thank you for having me.
Of course, man. So I am a huge believer that the most important part of every conversation are the people in it. So with that as a frame, can you tell us a little bit about who you are, how you found crypto, and like what eventually led you to Aleo?
Yeah, sure. So I grew up in a military family and then ended up joining the military, and spent 10 years in the U.S. Army, kind of late aughts to kind of late teens, I guess. And kind of in the middle of that process, I discovered crypto, working in the Middle East with people who, generally speaking, have a lot fewer choices than we do growing up in the first world. So specifically, I was working with Syrians as part of the Syrian. We were working with some of the Syrian rebels at the time to fight ISIS, and that's when I discovered Bitcoin and realized that Bitcoin is just a really amazing, powerful technology. Specifically for people to preserve and transfer their wealth in cases where, like in refugee type scenarios, right? And that's what got me into the space initially after my military career. Yeah, so I had this 10-year military career, had no computer science background, I guess it's maybe important to mention, and discovered this technology, which I was fascinated by. And so I wanted to get into the industry. I was just transitioning out of my military career, wanted to get into the industry, had no idea where to start. Like most people who don't know what to do in the next step of their career, I applied for an MBA program and was fortunate to get to attend Stanford, where I did that, where I completed my MBA and was also just moonlighting in all these different places where I thought I could get relevant experience for crypto. So that included, I helped found the Stanford Blockchain Club, and because there wasn't a pre-existing blockchain club, so that was great because we got to invite people who were experts there to kind of teach us what was the latest and greatest in the industry. I took a number of computer science courses from some professors there to kind of help me have build a technical understanding of how this stuff worked under the hood. And then I ended up working in a couple of the companies early days in the industry, including Coinbase. So I was an intern at Coinbase. I actually worked for Emily Choi, who's now the president of Coinbase. I was her intern, and then Max Brandsburg, who's the head of product. I was his intern. So anyway, so I worked there, and then ended up being fortunate to land a job at A16Z, Andreessen Horowitz, which is a crypto fund. I was fortunate to land a job at their first crypto fund after graduating, where I worked for Katie Hahn, who now has her own fund, Hahn Ventures. But yeah, that was my start working for her in VC. So I got my start in the industry, I guess if you don't count my Coinbase internship. My start in the industry was working as a venture capitalist, looking at different projects and, assessing, whether or not they were good investments, and then ultimately investing in and following these companies or these projects. And that was fascinating, incredibly fascinating, just mainly because of the time, the era that crypto was in, right? So you kind of had, early Bitcoin era, you had early Ethereum era, ICOs. I was just kind of getting into crypto right before the ICO boom and during, kind of as a hobby and personally. And then I entered A16Z right before what we now call DeFi summer. So it was kind of like there was a big bear market, and then everything was kind of picking back up. And a lot of these protocols that are now household names, these were kind of these were projects that we saw. Like I remember we saw one of the first pitches for Solana. We saw one of the first pitches for Avalanche. We saw Uniswap. Uniswap ended up being in the portfolio. So anyway, it was really fun to get to meet a lot of these entrepreneurs and founders and communities at these times before they were big. And I really enjoyed that. But I ultimately was looking for a different experience. I found investing was very educating and enlightening, but I found it less fulfilling for what I wanted to do. I wanted to be on a founding team. I wanted to be at some, working on some protocol that was going to make a first order difference. And so I was sort of contemplating what I wanted to do for the next step of my career. And, like I said, at Stanford, I had kind of taken some time to educate myself in cryptography and some of the trends there. And ZK, zero knowledge cryptography, was one of the areas that I was really interested in. And there was an acquaintance of mine named Howard Wu, and we had worked together at a couple of different spots, but most recently at Libra, or we worked with the Libra project, which was Facebook's ill-fated cryptocurrency. And he was I believe a contractor, and I was working with Katie just as she was with her board level kind of engagement. Anyway, so Howard was a cryptographer. He was starting this company called Aleo, which was based on a paper called Zexy, which is basically, Zexy or Zeeks, some people say Zexe. It's basically it was an extension really of Zcash or Zero Cash, which, by the way, shout out, maybe it was a good shout out for today. 10 years ago today, the Zero Cash paper was published, which really was the really the genesis of ZK and cryptocurrency, seminal moment there. So anyway, but several of those same authors from the Zero Cash paper collaborated to write the Zexy paper. And Zexy was basically an extension of Zcash to support smart contracts. So anyway, Howard was one of the co-authors. He was starting a company, Aleo, to build a protocol around this, and I got really excited and jumped in. And so that was kind of my start. And then I ended up, I guess just to finish quickly, I ended up holding multiple executive positions there. I joined as the chief strategy officer, became the chief operating officer, and then ultimately the chief executive officer before leaving. And we actually split the company into a foundation, nonprofit foundation, Aleo Network Foundation. And then Howard went on to, has remained at what is now called Provable Incorporated, which is like the labs entity.
Man, this is the first time I've ever regretted asking the background question, because I'm not sure if we're going to get to Aleo with the amount of questions I want to pull apart of like the most like compelling background I've heard so far. But I will control myself.
Hey, this is your podcast, so you go any direction you want.
No, thank you. But I want to talk about crypto. So the one thing that I will ask about, like, and to ask you to elaborate on from your background is this moment in Syria where you realize the power of crypto. Because look, like, I think for most Westerners, first worlders, especially Americans, and especially like my cards on the table, I went to Stanford too, like us of this like part of society, like we get involved with crypto because we see some interesting technology and a shit ton of upside. And like you can kind of like put your own little spin and spice into it, but like that's really like kind of the main channel for people getting in. And I think that as you spend more time here, as you have more experiences in the world, as the world starts to fall apart more and more, like you start to understand like the real values and see why crypto is important. But like you actually saw it and experienced it and like saw the promise of crypto long before like crypto got to a point that can deliver on that promise. And so I would just love to like, can you tell us a little bit about like what were you seeing in Syria? How is Bitcoin being used? Why was Bitcoin like the only channel where the traditional financial rails weren't helping? Like, can you just like help me understand in this moment where you saw that Bitcoin is like an incredible technology that matters to real people's lives? Like what was happening that gave you that insight?
Yeah. So just, I guess maybe just something to be clear on here. So there wasn't, first off, for me personally, there wasn't like a moment where I was like, oh, Bitcoin is the future. Wasn't a moment. And secondly, Bitcoin wasn't that used, frankly, in Syria. I think this is a misconception that a lot of people have, is like in these third world countries, it's very common to see this stuff. It wasn't commonly used. It was used a little bit. And the way I got actually introduced to it was very random. We were American Special Forces unit working in Turkey, training Syrians who would go fight ISIS within Syrian borders. And there were no Americans in Syria at the time. And so we basically had to fight ISIS by proxy through these rebel forces. And these guys they'd come over and they'd train, and they'd go back over, and then we gave them weapons and trucks and stuff, but they inevitably needed to like support themselves with food and fuel and things, and so they required cash. And so they're like, hey, is there anything you guys can do for us? American military, like your vast resources, we're this ragtag group, and we're like, yeah, sure, just come back to the border and we'll give you cash, basically. And there was some hesitance on their part, because you can imagine driving around the lawless area of northern Syria, driving around with a briefcase of cash or a bag of cash is like reasons, there's reasons why you wouldn't want to do that. And, and one of our Turkish partners who we were working with, who was from the intelligence community, was like, he's like, why don't you try paying them in Bitcoin? And, this is a bunch of American special forces guys who are like, we're not PhDs. So everyone's like, what is a Bitcoin? And so that was kind of how we learned about it. And then the whole conversation ended up being moot because, long story short, Russia intervened. Basically on the American, the flavor of the American, contribution there changed drastically. And a lot of the folks that we were supporting kind of ended up either permanently becoming refugees in Turkey or being killed. And I actually that was the second piece where it clicked for me. It was like a lot of these folks who ended up becoming refugees, some of whom who we'd worked with previously, their stories really struck me in that, like, they were, like you mentioned, the cohort that we inhabit, in our society, right? Like, there were several of these people who were in Syrian refugee camps were in the similar cohort within Syria, right? They were well off, they were well educated, they had plans to send their kids abroad for school, they're doctors, dentists, professors. And then they were in, one day the Syrian civil war broke out, and there's effectively two sides of the line, and if you were on one side, you were cut off entirely from the system, right? Banking system, financial system, legal system. You just were considered persona non grata within your own country. And then those people, it was, they were fortunate effectively that they were actually able to flee. Many weren't, right? And they were able to flee, and then they end up in a refugee camp where they're living hand to mouth. Literally, and they have no access to their bank account or their life savings, which in many cases is tied up in real property. And this is when it started to really click for me, because it's like, Bitcoin, oh, okay, should we pay, guys? And I learned a little bit about it through that. And then I saw this, and I was like, wow, like, this is shocking, really, to see people who had basically played by the rules their whole lives. The rules changed, and they lost everything. And then in that moment, I kind of had, like, if there was an aha moment, it was a little bit of like, if you had something like Bitcoin, if you were a refugee from a conflict, you could just basically put your whole theoretically, put your whole life savings in your head, memorize a a private key or a seed phrase, and then go anywhere. And then you can start over. And to me, I was like, holy shit, this is amazing. This is revolutionary. And that's what sent me down the path of really getting into the space. And then as I kind of was reflecting, I guess in closing, I'll say, as I reflected upon that experience, I was thinking about the rest of my military career too. And I deployed to Iraq and Afghanistan as well. And, those places also, there's like, enormous poverty and lack of basic systems to, enable people to participate in the economy, massive corruption, all these things I think blockchain technology and cryptocurrencies can directly address. And I think when you do see places where there is high Bitcoin adoption, like look at Venezuela, for example, you see this like relatively, and Turkey's another one, right? Turkey, I think, is a relatively developed country, but a lot of issues with inflation. Like people there are rabid for this technology. And I think they much more than many people in the United States, at least, understand its relevance.
Awesome, man. That is so incredible and like interesting and eye-opening, and I'm forcing myself to stop here so that we can talk about like today's crypto and like the things that we're building. But I do think it's important for all of us to remember that like this isn't just like a VC merry-go-round. Like this has like real implications, whether it's like these most like devastated, war-torn places, or just like regular moms and dads who like want to like give a good life to their kids in Argentina, but like literally can't because their savings gets eaten up faster than they can earn it. And so I just, actually, this is a good segue. I think that the ZK era is kind of like the herald of this new era where we move away from just like VC speculation and into like true applications and like things that people want to do with this. But it's important to remember that like that if you're not in the space for that, honestly, like there's more legal ways to make a lot of money.
Yeah. Well, but I think we're getting to the point where these products that crypto enables are going to become essential. And in particular, I'm very bullish. I mean, obviously, where you stand is where you sit, I guess, but I'm very bullish on the combination of ZK and crypto networks, particularly, and we can get into this more later, but like in the era of AI, where content is going to be generated by all kinds of agents, mostly non-human, how do you know who you're interacting with, right? Like it's already a huge problem. Spam calls, spam emails, spam everything. I mean, just like that problem is about to a million X. And understanding who and who you're communicating with, under what rules, the conversation is guided by, that are cryptographically guaranteed, and those two things being cryptographically guaranteed, that is exactly what crypto and ZK can do. And I think that's why, like, we're just at the beginning of this technology. And while it is very important, all the use cases you mentioned that I also was passionate about, in the third world, like, just to be clear, there's very relevant use cases coming for all of us, I think.
Yep. No. Point taken. And what I like, you go on crypto Twitter right now, like there's clearly some sort of intersection of AI and crypto just based on the amount of money going through it. I think we all have opinions on that. And it's like, whatever, we all have opinions on that. But what I do always say is that I don't know what the intersection of crypto and AI is, but it's so clear that these are the different sides of the same coin. And that's because that crypto is about about scarcity, and it's about slowing things down and about identity. And AI is about abundance and speed and just like creating as much as possible. And so again, I'm not sure where these exactly come together. I think the guy that does is, the next Hayden Adams, right? But actually, hopefully it's the next Alex.
Or this Alex, ideally, but,
Well, yeah.
Only time will tell if it's me or the next me or Hayden Adams,
Yeah. No, but anyway, okay, so let's talk about Aleo. And I want to go back to this moment of like the inception. So can you talk a little bit about, like, from first principles, like what were you trying to build? Why did you decide to go specifically? The two things I want you to address are, one, as like a ZK as a core primitive of this L1 blockchain, and then two, why an L1 blockchain?
So starting off with ZK, so I think first thing to me, I think ZK was as magical of a technology as I could have imagined. And I think it's often conflated with magic, which is sometimes unhelpful, but it really is amazing what you can do with it. I mean, it's this mathematical, it's basically a set of mathematical algorithms that let one party prove something is true without revealing why it's true. There's really no physical analog. It's kind of crazy if you think about it, where it's like if you and me are playing poker and I'm like, hey, I have two pair, and you can just trust me. Like, you would never trust me if we were playing poker. Right? You want to see the two pair before you're going to hand over the money. But in this paradigm, using cryptography, you can actually be cryptographically assured that I do have two pair without having to see my cards. There's no physical analog. And so to me, just that fact that there was this new capability that didn't exist in the real world got me really fascinated by ZK before Aleo. And then in particular, I think as it's relevant to cryptocurrency and blockchains, I think one of the major drawbacks, there's two major drawbacks in my mind of most early, certainly crypto networks. I think subsequent crypto networks have addressed this or have tried to address this, but one of them is just a lack of data confidentiality, right? A lack of privacy. Like if I send you $10 right now in USDC on Ethereum, like that transaction's there for all time that everyone can see. It's searchable by anyone, right? Now, you may or may not use an ENS address or an ENS name. So like maybe it's harder to figure out who you are. But the bottom line is like this ledger is fully public. And for any number of real world use cases, that's a big problem. And this is why I think you see, I mean, my favorite question to ask at every crypto conference is, how many people here take their full salary in crypto? And the answer is inevitably no one, despite the fact that everyone is talking about how this is the future of finance. And it's because there's a social norm around salaries. Like, how much do people make? You don't want to publicize that, right? And so it's kind of a silly example, but it just gets to the heart of like why I think you're not seeing as much adoption for crypto for real world use cases. Now, what is the killer use case for crypto up to this point?
Yeah, speculation.
It's gambling. It's a different form of casino. And by the way, like I have nothing wrong with casinos. I've been to Vegas. I like playing craps. But like the point is, like, we can't pretend, I think, that we have somehow created the future of finance yet, right? Because we haven't solved these fundamental problems. And one of which, like I said, is the fact that we can't have a financial interaction and not publish it, right? So ZK is a solution to that. ZK enables us to have a financial interaction, not publish it, be assured among each other that the transaction was valid and within the context of the system. right? By the way, you can apply a whole bunch of compliance to that too, and we can come back to that later when we get to the inevitable criticisms of this model. Um, but yeah, so that to me was one aspect. So ZK I think really solves the problem of privacy, and then the other problem it helps solve is scalability, right? The other big early blockchains in particular suffered was you just a limited transaction throughput, and ZK, as we've seen with ZK rollups, provide this nice paradigm because in addition to being able to prove a fact without revealing why it's true, it's a nice mechanism for compressing a bunch of computation into a single succinct proof, which is how most layer twos, the commonly referred to as like what is it, ZK EVMs, like this is really what they do. It's not really about protecting or preserving the confidentiality of a computation or of an interaction. It's more about like compressing a bunch of interactions into one succinct proof. But you get both with ZK, right? So that's, I think, the cool part about it. Now, why a layer one? I mean, to me, the three fundamental principles that we wanted to achieve was data confidentiality, the privacy, and then scale, like being able to perform computations at scale, and then permissionlessness. And I think for me, permissionlessness is it's funny to have to say this in a crypto podcast, but I think it needs to be said. Like, it is a fundamental principle that differentiates cryptocurrency from many other tech stacks, right? And I think if you look at most of the other L2s out there today, there's a lot and even many L1s, there's kind of a theoretical roadmap towards a decentralized layer two. And I think the reality is these things are pretty much run on AWS servers, right? And there's not a lot of real interest in progressing that roadmap. In fact, I had a tweet last year where I was joking, is the road to L2 decentralization going to take longer than the road to ETH2, right? And ETH2, people were famously upset for how long that took. But I think, frankly, in fact, that kind of looks fast compared to a lot of these, a lot of these L2s have launched 4 years ago and still don't have fraud proofs enabled, for example. So I think for me, permissionlessness, like L1s are nice because look, the assumptions around permissionlessness are well studied and very explicit, right? It's like, there's actors that aren't related to one another. They do work according to some, according to the protocol, and then they're rewarded according to that same protocol. And then everyone checks each other, right? And so the economics, I think, are pretty simple. And, I think from that, you do get the best guarantee that we know of a decentralized system there, which therefore gives you permissionlessness, right? As a user, I can go interact with, let's take a very permissionless system, Bitcoin. Like, I can just, send a transaction to your node, and if you just reject my transaction, I send it to someone else's node, or I run my own node. Like, there's no gatekeeper. I don't have to rely on AWS keeping a server up, or relying on a company or my bank to decide that I'm bankable, right? Like, we have all these systems that, by the way, work great if we don't care about permissionless, right? Well, when the rules are set and nobody, there's no ambiguity there, banks are fine for financial transactions. But if there's any ambiguity, and by the way, in cases where there's two different banks trying to interact with each other, that's where we see the big opportunity for crypto. But to solve that, you need permissionlessness. So that was really why we went the route of the layer one and ZK in particular.
So I want to get back to the layer one thing in a second because this is just too dense of a conversation. But so put the layer one thing aside and just to talk about ZK real quick. So I am so with you that if magic is real, it's ZK. And no one who doesn't already understand this stuff will understand what I'm about to say. But the idea that you can take a number and somehow hide it behind a relatively simple equation and then use that to access that information, but it's also lost forever. It's it is one of those things, the more you learn, the more you're just I think magic might be real. I think God might be real. This can't, how, And so I feel you with that in that sense of awe and wonder. And the other thing I wanted to say about ZK, so I think it was about a month ago, sorry, Anna, I can't remember, but on Anna Rose's Zero Knowledge podcast, she had a guest come on who basically came out and talked about we're in this weird situation where we have this term zero knowledge, and what that formally means is about a prover being able to generate a proof without a verifier having any information about it. And yet in blockchain, about 90% of the time what we mean has nothing to do with that and is really just about succinctness. And so I started this conversation being oh my God, this is so pedantic, who cares? But by the end, I'm you know what? There's actually something profound going on here where like maybe ZK, the two letters, kind of refer are a category, or maybe ZK refers to succinctness, while zero knowledge refers to this like privacy thing. And I think with what you're talking about with Aleo, like that distinction kind of collapses back down again because you want those things. But I do think it's like kind of important to put out there because like you kind of really can't understand the all-encompassing nature of this technology without realizing that like zero knowledge is super important, but like that's not even really half of the juice.
Yeah, yeah. And I think, look, so first off, I strongly agree that I think there needs, it does feel pedantic, but it is I think it's important to clarify what we mean by different terms, right? Zero knowledge, as you pointed out, has a very specific academic meaning, right? And you stated it. And that's not what a lot of people, who have protocols that are some way referencing ZK do, right? And it's not necessarily a bad thing, but I do think for the industry, it is important that we have some rigor around how we refer to things. And I think this is unfortunately one of the things that I think holds the industry back is that because a lot of the use cases are speculative in nature, there is a deep desire to tap into trends, right? In order to you kind of were joking about like the crypto AI thing earlier, right? Like everybody, it's like there's always a desire to trying to tap into trends, which at some level is fine, right? You want to make sure this technology is relevant. That's okay, right? But I think done too liberally, I think it kind of dilutes what these things actually are, and I think it confuses rather than empowers people, right? Even the term zero knowledge, I think it's honestly even that is like too pedantic. And the AI, to be clear, I'm not knowledgeable about AI very much, but I kind of see some similarity between I vaguely remember 6 or 7 years ago people talked about transformers, right? Like people got into the level of like how transformers work, right? And I don't know anything about transformers, but now it's like people are just kind of like, hey, we have LLMs, right? I'm assuming somewhere in an LLM there's like transformers or things, but like we've abstracted that, right? Now there's a layer of abstraction, and everyone's like, oh, LLMs and GPTs, right? And that's where ZK is ultimately going to exist at some level of abstraction, right? Where you have a product, you're like, hey, I want to log in with using my passport without revealing it. You're like, okay, I do it. And then it's like, oh, I use cryptography. And ZK is one of the things you use, but like it maybe is like, you don't, we once we get to that point where there's real products that solve real problems, we won't have to worry about having these debates, which I agree are pedantic, but nonetheless important.
For sure. No, I'm a huge believer that yeah, like right now we're essentially touching bare metal. Like this stuff is so low level, and like I never ever think that grandma is going to touch crypto anything. But I also don't think that like grandma knows anything about like hardcore like internet networking or routing and switching. Like, but she does know that you have to type in HTTPS colon slash slash. And like that's where I think that crypto is inevitably going, is that like you'll see some artifacts that gesture to the technology we're building, but like chains, DeFi, all this shit, no, like you'll feel like a banking app.
100%. And I just to touch on that quickly, because I think this analogy I use all the time for Aleo, like crypto today from 99% of protocols, Ethereum, Bitcoin, many others, is HTTP, right? HTTP. So, and I sadly am old enough to remember the internet before TLS. And like at the time, it was a lot of message boards, right? People had message boards, and that was basically what was done on the internet. People communicated with each other at universities, etc. And then Netscape famously created, SSL, which ultimately became TLS, and that enabled encryption, and that enabled credit card transactions. So merchants could then sell online, and people could buy things online without having to worry about third parties snooping their credit card data. And that was the moment which unlocked the web in terms of economically unlocked the web, right? And of course, there's a ton of economic, already tremendous economic value in crypto, but I think that moment we still haven't had. And this is what we're trying to build at Aleo. And this is what I think ZK in particular can enable, is the HTTPS for Web3.
Awesome. All right, so let's go to the layer one conversation. And I want to just throw something out there as like an embarrassingly, but I'll call it myself like an Ethereum maximalist, right? Which is, I actually don't think that the point of anything that we're doing is building technology, right? Like I think at the end of the day, we're building like Turing complete machines that are about as capable as like the the computer that got us to the moon in the 70s, right? Like if you are actually interested in building high performance computing, stop with all of this and like start working on like centralized computing. I think what's interesting about crypto is that first through Bitcoin, and then my opinion is that Bitcoin got like so politicized and so like stuck on this like gold money issue that it like we had to try again. We created Ethereum, and like the special thing here is not the technology, it's not any of that shit, right? It's that it is a credibly neutral shared space. And like that, going back to the stuff we were talking about in Syria or like whatever, the point of crypto, I believe, is to create a shared space that like can serve as like the substrate for property and identity on the internet. And so like every time I like look at a crypto project, my thought is like if you start at like, okay, we understand we have a shared space, we're going to get rid of that one and start over, I like automatically struggle because like one, it's like again, not necessarily congruous with how I think like the point of crypto is, but two, it's just like if that's our attitude, why in 2 years when there's newer ZK tech shouldn't we be like, Aleo, that's cool, it's a shared space, but let's trash it and start over?
Great question. And just to be clear, I love Ethereum. Ethereum is amazing. I was an Ethereum community member long before I was at Aleo, and I still am. I still proudly am. And it's interesting you pointed out Bitcoin. I think these are communities, right? So these are not only technologies, but these are communities. And this is one of the most fascinating parts about cryptocurrency is like it's the amalgamation of like kind of the most technical things and the most social things. It's like the PhDs from like computer science and PhDs from social science got together and created a thing. But anyway, yeah. So different community, like the technology in many cases kind of represents the values of these communities that birth them. And to be clear, this is technology, right? So every choice has trade-offs. So Bitcoin, for example, would criticize Ethereum for the trade-offs that it has made around block size, right? They're like, hey, you have all these blocks, they're very big, everyone's doing smart contracts, but then how is anyone going to run a full node, right? When it's 20 terabytes big? That's what a Bitcoiner would say, right? And they're right at some level. If you think that running a full node is really the key thing to permissionlessness, then that's a valid point of view, right? Now the Ethereum folks are like, well, that's great. I can't do anything with Bitcoin. So what's this like? Who cares? We're going to have to, buy it and hold it. It's gold again. Like, what are we even doing here? Right. That's fair too. Right. And I think for us with Aleo coming into this, like, why do another layer one? First off, we would have done a layer two if it was possible. And by possible here, what I mean is if we didn't have to make the trade-offs that we would have had to make technically. And I think fundamentally, some of those trade-offs that we're living with were made in the early days of Ethereum at the level of the EVM. Let me just give one great example. Kachak. So Kachak is the basis of the SHA-2 hash function. It is used everywhere in the EVM, right? Kachak is almost 90% of, I feel like, the EVM, right? Because all of the state is represented in these different state tries. Kachak is used every time there's generating an address or something like that. So it's just constant, it's everywhere. Now, what is the problem with Kachak from the perspective of ZK? Well, ZK operates over these things are, you basically have a program that's encoded as a circuit. You could think of like a circuit board, zeros and ones, right? And when you're encoding a program like that or a statement, that kind of the size of that statement kind of directly correlates to how long it takes to prove something and or verify it, depending on the proof system you're using, right? And the problem with Kachak is that when you take that algorithm and you put it inside of this ZK circuit, it's massive in size, right? So which is to say that it's very expensive to do in ZK, right? That's why if you look at all these teams that have taken, they're like, hey, we're doing ZK EVM. That's why Vitalik wrote this great blog post, which you probably remember, was like types of ZK EVMs. And, people like kind of increasingly contort themselves to say they're equivalent, but like this is one of the areas where universally no one is equivalent. They all remove the Kachak hash function to use something snark friendly like Poseidon, right? So it's up to the listener whether or not you consider that equivalence. But nonetheless, the point is that there is very much, that's just indicative of the trade-off that's made, which is that Ethereum was built without the ZK in mind, right? It kind of evolved in a direction where this was desirable, but it was not built with that in mind. And of course, you can't just switch everything because you've got Uniswap that's deployed, right? You've got all these deployed programs. And by the way, it's even worse than like traditional software where you just like push an update. Here, these things live on a blockchain. There's a smart contract that's there and it's long lived by design. So it's very non-trivial to do any kind of migration. I mean, I actually think, being complimentary of Ethereum, I think the ETH2 merge was incredible. I mean, that people do not appreciate that accomplishment enough, given the number of parties involved and the number of interests. Anyway, for Aleo, we decided to take the approach of like, okay, look, starting with this technology, which we think, you and I consider magical, ZK, we think that it can enable a lot of really interesting user interactions. I agree with you. Identity is one. And it enables these properties of privacy, data confidentiality, permissionless, and programmability. So how do we start from first principles and build a VM just for this? And then how do we build a blockchain around that and build from the ground up? And then I think there's still, it was and still is a desire to interoperate with every other crypto network that's out there to the extent that it's relevant, including Ethereum, right? I mean, day one, we're planning on having multiple bridges over to Ethereum, et cetera, just like many of these other networks do. Solana is another example of a network that took a trade-off of like, hey, this could be way faster if we all didn't run small computers. What if we had like a handful of people running really fast computers and data centers? That was Solana based. I'm sure Anatoly would kick me for saying that, but like that's how I think of it, of Solana, right? And so these are trade-offs. So anyway, we decided to make the trade-off like, hey, build this thing from the ground up to support ZK. That means we're not going to support Ethereum smart contracts out of the box. We'll have to figure out other ways to interoperate. But I think that's how, if you look at a lot of traditional web technologies, that's how it started too, right? You have a bunch of these competing standards, and you kind of over time like overlay different ways for them to interact. And then ultimately what you end up with is the web. And that works pretty good, despite the fact that honestly at a pretty low level, it's pretty, balkanized.
No, I think that's fair. And when I'm trying to make the Ethereum maximalist argument, like I often go straight to JavaScript, which is like this like really weird language that like especially 20 years ago, like it didn't really work. Like it was super idiosyncratic and strange. And like if I had $1 for every single team that were like, we're going to do a JavaScript killer, it would like, I would not be having this conversation from you from this like kitschy home. Like I'd be on my yacht. Right. And I think the lesson from that is like, it is not about the best technology ever. It's about like, this is what we have and this is what the community uses, and let's like collectively push it forward. But I think the point that you're making is that like, yes, while there was this maybe like core that is the community pushing JavaScript forward, the reality is there's like a ton of different languages that you can write web programs in and like maybe compile down to JavaScript, or maybe have reached a big enough size that browsers support it or whatever. And like the point is that all of this is abstracted away from users, and they just experience it as like websites. And so I still believe what I believe, but like your analogy or the way you talk about like this balkanization underneath the hood, but like because of the interwovenness of these technologies and how they are ultimately supporting applications and like user interactions and not like just technology for technology's sake, like gives me a clearer picture to what a more diverse world looks like.
Exactly, because you think about a web app, I mean, like just this one we're using right now. I mean, under the hood, I'm sure there's JavaScript, but there's other web technologies too. There's probably some database somewhere in the back end. Like, not you or me don't have to care about that, right? We're just like, hey, we're having a conversation. This is a podcast getting recorded. It's magical, and that's great. And that's ultimately where crypto will get, and that is where we have to all continually focus. And my view is that Ethereum. I remember when I started at A16Z, I remember there were critics of Ethereum. They were like, no one is going to want to learn a new smart contract language, Solidity. It's like, no way. Hey, people swore up and down it was dead on arrival. And now, of course, that's the argument that people make today about other languages. They're like, no way anyone's going to learn anything other than Solidity. And of course, those are both overstated, right? But the reality is these things are going to grow towards the direction where there are real world applications, right? And these technologies need to start evolving and will inevitably start evolving in that direction to serve an end use case. Because right now there's like a lot of investor money, there's a lot of speculative frenzy. Ultimately, at some point, this will have to find a problem and be the solution for it, right? And that will ultimately be what drives what this looks like. Whether it's Aleo, whether it's Ethereum, whether it's JavaScript, whether it's Python, ultimately these things have to be tools to solve a problem.
Yeah, I love that, man. I love that. I love that. Like, it's not just about speculation. Like, we actually have to go find problems and solve them. So let's move out of like debate lord world and go like straight into Aleo and like help me understand like what. So let's start with a generic blockchain, and then help me understand, because ZK is built into Aleo, like what, just on first principles, like does Aleo provide both like end users of the blockchain apps and like developers who are trying to build those apps on them? Like, what is special about Aleo?
Yeah, so let's talk about it, and let's just, one way I like to describe this is kind of looking at like the history of blockchains, how they evolved, and kind of where Aleo fits there. So let's start with Bitcoin, right? Bitcoin's big innovation, and people forget there were like 50 protocols that preceded Bitcoin that all failed at trying to be digital money, right? And Bitcoin's innovation was this concept of economic security, right? So you have this economic security guarantee where it's like, hey, we're all miners, and like, we're gonna do this, grind shot, 256, and then earn rewards. And if anyone screws up, we'll take their money, or they'll forfeit it, right? And so basically, everyone was kept honest by the rules of the protocol. It was just like able to have this Byzantine network of actors work together, right? Downside, well, you couldn't really do anything but transfer money around, right? So then Ethereum came along, and Ethereum's innovation was that, hey, wouldn't this be cool if instead of we just had value transfer logic, we effectively kind of built, a virtual machine on top of this. Therefore, we could do smart contracts and have real like functioning programs, right? Which required some kind of a reimagining of how Bitcoin worked under the hood. I mean, it's very analogous, in fact, to what I was just saying about Ethereum. It's like, Bitcoiners would be like, well, you can write smart contracts. Just write Bitcoin script. I don't know if you ever tried to write Bitcoin script, but it's not as not as developer friendly as JavaScript. Let's put it that way. But anyway, so Ethereum took that direction. They said, hey, we're going to basically build a blockchain around this VM. And that's what they did. And that, enabled the world of smart contracts. Now, Zcash actually went a different direction with Bitcoin. They were like, said kind of similar things to what I said earlier in this podcast around, hey, real people, real businesses need some level of confidentiality for their interactions, because otherwise it's dead on arrival. So they basically said, okay, we have this Bitcoin model. Let's use ZK and basically have this so, everybody doesn't have to share every interaction. And that was the direction that Zcash took. And so Aleo is trying to merge those two directions back together, the programmability and the privacy piece, right? So what does it look like fundamentally? Well, we started with a VM, right? And this VM is, and this is, by the way, I referenced a paper earlier in this podcast, Zexy. That is what this is. Zexy is describing a virtual machine meant to be run on a distributed network, like blockchain, that uses ZK to affect state updates. Now, the mechanism by which the virtual machine does state updates is very similar to how Zcash does it, although you can think of Zcash effectively as a special case or a program within a broader Aleo context, right? So Zcash only handles value transfer in the same way that Bitcoin only has value transfer, and Aleo enables many of the rich interactions that you could expect on Ethereum. And so that was what we started with Snark VM, and I can talk at length if you want about the Zexy model and why it's different, why it's not actually that straightforward to port over Ethereum to ZK. But we'll leave that aside for a minute. Then we built out this blockchain, and we said, hey, what properties do we want this blockchain to have? Fundamentally, it needs to be permissionless. So we adopted a version of Narwhal Bullshark proof of stake consensus, which is an iteration of hot stuff, a version of which is what powers Ethereum. So it's kind of like basically taking the modern proof of stake architecture. And then the only kind of twist we added in is, to achieve another goal was we want ZK to increasingly become practical, right? And one of the powerful things about a network like Bitcoin is it drove enormous investment into the generation of SHA-256 hashes, which I think is pretty useless, but you can imagine that like that economic incentive is powerful, right? There's billions of dollars been poured into that. And so what we wanted to try and do is really to create a form of useful work and an incentive for which people to invest in this low level kind of ZK hardware, basically to make it better, to go from like, hey, because, theoretically, for a ZK proof that you do on Aleo, you probably do it in your browser. Might take a few seconds depending on what you're doing. If you had it on the GPU, it could take a fraction of a second. Maybe if you have an ASIC someday, you could do thousands of proofs in a fraction of a second, right? So just like semiconductors have kind of advanced over time, miniaturized, more specialized, faster. I think there's an arc for that in ZK. We wanted to bootstrap that process by building in this incentive mechanism. So there's effectively what I'm saying. So we have a proof of stake network with kind of this like rewards mechanism that operates alongside, which is basically a proof of work network where provers generate proofs for the protocol to receive rewards, right? So that is really there, not really for the security of the network or anything, but as a means to bootstrap or create a business for provers who ultimately can also serve consumer use cases too. So if you imagine like a common go-to-market strategy for a lot of roll-ups and ZKVM providers is this like, hey, our software is going to power a proving as a service stack, right? So it's like you Rex come to me and you're like, hey, I want to prove a statement about myself. I want to prove I'm over 18 or whatever. And Alex, you generate the proof. And I do that for you, and then I give that back to you, and you send it on to whatever blockchain or whatever authentication service, right? Now, the reality is like that would be great if that service existed, because you could basically take advantage of the same reasons why the web went to client server model. Servers are powerful, clients are weak. You could outsource the heavy computation of the servers. The issue is though, like there's no market. Right? Like a market kind of needs two sides, right? There needs to be suppliers and people who want the thing, right? And right now, there's just not that much demand for proofs. Therefore, there's no incentive to invest in this market, which is what we're trying to solve with this Coinbase puzzle. This is exactly the thing we're trying to address. So that's the VM. And then there's the blockchain. By the way, the VM we call SNARK VM. SNARK stands for Succinct Non-Interactive Argument of Knowledge. That's kind of a ZK wonky term, but if you hear SNARK, that's what it is. And so SNARK VM is our EVM equivalent. SNARK OS is our blockchain. It's like our node implementation for this node running Narwhal Bull Shark consensus, and the EVM or the SNARK VM on top. And then we have Leo, which is our equivalent of Solidity, right? So Leo is a language by which you can write. It's kind of JavaScript, Rust combination of like syntax, and you can write human logic, high level logic that will be compiled down into what are called Aleo opcodes, which then themselves are synthesized into these circuits, which are fed into SNARK VM, right? And then those circuits and that logic is what defines how value transfer happens, right? According to whatever logic you encode. So that's Leo, and that's kind of really the last step or the last bit.
Alex, why did you let me go on and on about like Syria and L1s when there's so much interesting stuff here? I can't even believe we have like only 15 minutes left. So,
well, we can do a sequel.
Yeah, we're doing a sequel, but let me try to keep this succinct. So, okay, first, let me try to pull out like the most interesting thing that you said to me in describing what Aleo is, which is, and correct me let me know if I got this right. So what you said is for Bitcoin, what like the core difficult thing there was like doing this SHA-256 hash. And because like that was both like so critical, because it was so critical to Bitcoin, we for the last 15-ish years have seen VCs, publicly traded companies, like pension funds, whatever, just dump like investment into making that SHA-256 hash like faster and faster and faster as possible. And what the realization was is like that work, that SHA-256 hash, is like only useful in the context of Bitcoin. And the aha moment is like, okay, what if we design our protocol to do a similar thing in that like we have this core primitive that's going to need to run like millions and millions of times. So it's going to like require and incentivize a ton of investment. But let's design our protocol so that that core primitive is useful beyond just this protocol. And the idea is that now this investment will not only go towards Aleo and like bootstrapping the system, but will also create investment and infrastructure into general purpose ZK proving.
That's exactly the idea. Now, for anyone of your listeners who may be hardcore Bitcoin maxis, let me just acknowledge that the trail of trying to take a useless proof of work algorithm to a useful one, there's a trail is littered with bodies, right? Like there's so many attempts that have failed at this. And this is actually like maybe it's an important point to note. I mean, Aleo has been around 5 years. An earlier version of Aleo was actually entirely proof of work. There was no proof of stake at all. And what we found is that it's very difficult to design a puzzle that is fair in terms of like the amount of work you put in is proportional to the amount of rewards you get out. That is non-amortizable, which is for a variety of reasons we won't get into, a very important property of these schemes, and actually gets you to like the end goal that you just described. So this is kind of why like we went away, just a bit of Aleo history here. We were proof of work, and the entire Coinbase puzzle was our equivalent of SHA-256. And then we had a test net where this was broken very publicly. where like one team just dominated it, and it was clear that we was going to be insecure going forward in this model, and that's when we switched to a proof of stake consensus, but kept and iterated on this Coinbase puzzle such that to achieve exactly what you described, but in the event that someone with billions of dollars understands how to ultimately exploit this, the consequences, while severe, will not be the same as like destroying the protocol, right? So it's basically a risk mitigation mechanism. Anyway, just a side note.
No, awesome. And so this so is it? I'm just going to say that like maybe Aleo consensus, it's like got this proof of stake path that is actually about securing the blockchain, and then has an independent proof of work path, which help me understand. So does this independent proof of work path is completely independent of crypto economic security for Aleo, but does provide services that are relevant within the Snark VM?
So let me try and elaborate. So what are the crypto economics? So there's a starting supply of Aleo credits. Aleo credits are inflated, or there's inflation through one of two sources. One is these proofs, right? So if you submit a proof that's above a certain difficulty threshold, then you get basically paid out for that work, right? In the same way that Bitcoin kind of works. The only nuanced difference between this and Bitcoin is that actually, like, kind of natively in the proving logic, we pay out proportionally. So Bitcoin's winner take all, and then for us it's proportional by block. Kind of just a little nuance, doesn't really matter that much, but I thought I'd mention it. That's one source of inflation, proving rewards. But one important note, though, is that anytime a prover finds a solution, actually part of those proving rewards go to the validator that created the block. And that's important because if you don't have some kicker to the validators that are ultimately creating blocks, the validators have no incentive to include those blocks, right? Because they're just being inflated. So there's kind of this kicker. So it's like it's 2/3 of the prover, third of the validator. Then the second source of inflation is for actually validator rewards themselves. So validators, just like other proof of stake networks, need to be compensated for the risk they're taking for locking up their capital, and for also, for doing the work of like creating blocks and, running consensus for the protocol. So that's the second source. There's this like staking kind of validator reward. And there's this proving reward. The proving reward, provers could stop doing anything, and the blockchain would progress as normal, right? So the proving reward, you can kind of think of it as like, one way to think of it is basically like a lottery for which there's an on-chain smart contract. And to get tickets, you got to submit proofs of higher and higher difficulty, right? So it's almost like that's sort of the economic way to think of it. And ultimately, the proving rewards start out to be very lucrative. They're the majority of the inflation, but over 10 years, they decrease to zero, right? So again, and now back to your question of how is this relevant if I'm a prover earning these rewards, what else can I do? Well, the nature of this puzzle is such that it's a large majority of the steps that are required to generate a zero knowledge proof for like an Aleo transaction, right? So theoretically, if you get really good at generating these proofs, you're going to be really fast at generating Aleo transactions, or maybe they'll be really cheap for you, right? And so then that has effectively bootstrapped your natural pivot after the Coinbase rewards go to zero is going to be like, hey, users of Aleo blockchain, of which hopefully there are many, use my service. I have a fast, cheap proving service where you could basically, work with me, and then I'll, submit proofs for you. And then that makes the barrier to entry for users lower. Fees are lower. Things are faster. And then it enables a bunch of other applications on top of that, right? In the same way, like, again, this is kind of pie in the sky future, but like, you think about all the things the iPhone enabled. You pack a computer into a small package. It's not really like, none of the pieces themselves are novel, but it's just the fact that all these things are together. And then because those things are together, now there's a bunch of new applications that are possible that then people can build towards, if that makes sense.
Yeah, it does make sense. And I guess my question for you is like, so totally hear you like on the role of this proof of work network directly to Aleo, and like how this, you've created this like natural pivot that like is very useful for like these inflationary dynamics that you're creating. My question to you though is like this work, this again, that is being done in the proof of work side of Aleo. Like, could I conceive, let's say as a user right now, like I want to go generate some transaction on Starknet, but I really don't want to use like the Starknet RPC or whatever, because I know that my transaction, if I have to give them all the information, will leak so much information that like someone's going to move on it. Maybe instead I could take all of the components, send that to Aleo, have them generate the proof, and then even though that proof is like completely irrelevant to the Aleo network, it's still like using the Aleo service for proving, and then I can take like that final proof and send it to Starknet. Is that like at all part of the system you're building, or is it really like the proof of work for Aleo is really relevant to Aleo and not so much else? It's just that the investment in the R&D will be relevant to other stuff.
Oh, there's so much in there. Let me try and pick apart and take like the answer succinctly, because it's a really important question you asked. So first off, I want to just distinguish one thing between Starknet and Aleo, right? This is an important distinction. Starknet, you can't generate a proof for yourself, right? Like you have to use their API, and that's a requirement, right? Because their prover is closed source, A, and B, it's actually pretty intensive. So even if they open sourced it, like a Stark prover is not something you're going to run on a client side device, most likely. In Aleo, and this is one of the reasons why we built Aleo the way we did, is that we very much wanted to ensure that you could generate the proof for your transaction alone with your device, whatever. Like there was no barriers to you doing that. The reality is, it's just like I use Gmail I could run an SMTP server, but I use Gmail, right? Like it's like the reality is most people are going to choose convenience. But I think that choice of being able to interact directly with the protocol is to me gets back to the core of permissionlessness. Like if we're not going to keep that, then what are we even doing? So anyway, so back to the question about could an Aleo prover generate a Stark proof for Starknet? That is an interesting question, but I think it's a little bit of two concepts, right? Like Aleo, the network, has its own like encoding of transactions and like what validators are going to check, and then there's like a theoretically off-chain service that could have been bootstrapped by the Aleo proving rewards, right, that then could offer services to multiple networks. And I think that's very, very true. I do think it's likely, at least in my mind, that you're going to see specialization around specific use cases for different proof systems, right? So Aleo has kind of, we've chosen a specific proof system. Starknet has a specific proof system. Other, Polygon that uses Plonky 3 has their own. So you've got all these different things that are kind of incompatible, and whenever you're optimizing something, you want as few choices as possible, right? So you want to I want just like SHA-256. You're like this thing and this thing only, right? And that's really how you get the real kind of juice from the squeeze for optimization. And so my gut is that I think certainly that Aleo will drive a lot of investment in ZK hardware. In fact, we're already seeing that. And I think a lot of that will translate over. Beyond a certain point, though, I think if you want to talk about ASICs, you're not going to see ASICs get developed unless it's specific for a use case, specific for a proof system. And those will not translate across ecosystems.
Yeah, well, let me throw this big one out there. Maybe we can walk out on this, but the way you've kind of framed Aleo, the holistic system, is that it's really an L1 blockchain, and that's what you're building, and you're creating this parallel proof of work structure that not only has some interesting properties, but is really about bootstrapping the Aleo blockchain.
Yeah, the prover networks, exactly.
Yeah, my question to you is, now that we're an hour into this conversation, am almost seeing the reverse. We have so many blockchains, and honestly, we're getting to the point where we have so many ZK blockchains, to even the point where it's just who cares? We need apps, man. We need apps and reasons to use this. And so why I am so bullish on what you're building now at the end of this conversation has really nothing to do with built a Snark VM or any of that stuff. The problem that this industry is about to face is that even once we optimize all of these ZK proofs, that it's not casual to do them, and we're going to need to come up with infrastructure and services and systems in order to make a ZK powered world, whether it's related to blockchain or completely independent from blockchain. We're going to need something to make that work. And so I guess my question to you is Aleo really a general purpose L1 blockchain that is bootstrapped by a prover network, or is it a prover network that's bootstrapped by an L1 general purpose blockchain?
Ooh, wow, great. I think it's both. Ideally, it's both. I mean, right, we're at the beginning and just I guess to maybe as a quick note before we end the show, Aleo is currently in testnet beta, which we just launched this week. Mainnet's launching later this year. And then we'll, I think, ultimately know the answer to your question of what's the prover network? What's the network like? How do those two interact? But I think in the perfect world, it's both. And I totally agree that ZK has application beyond just Aleo. In general, this is why I got into the industry. I think 20 years from now, ZK is just going to be part of the fabric of the web. And And I think something like Aleo will be too, mainly because I think blockchains are great when it comes to value. You mentioned identity and property. I think your framing of blockchains as spaces by public spaces by which identity and property are managed in the digital world. I couldn't agree with more. And to me, I think identity is one of the use cases I really like to focus on a lot, because I think, to me, you need the combination of programmability, permissionlessness, and privacy to do a good identity protocol, right? Like, imagine, like, even just let's take a problem on the web that's still unsolved to this day. Age verification on the internet. You want to go go to a beer website. It's like, are you over 21? You literally just click a button. There's no check. I mean, there's literally no check at all, right? And you can imagine all kinds of other content on the internet that, like, I have kids, and I would prefer my kids to not be able to just wander into, right? But it's very difficult to solve without giving away all of your identity information, right? And people don't want to do that. But I think you can imagine a ZK protocol like this, where it's like, hey, I upload my identity document, it's somehow validated via smart contract logic, verify the signature or whatever. Now this is there, and I can make proofs about it to whatever third-party service, and that third-party service is like, well, I got this proof. Here's the proof. The proof says this is a valid identity document, and that these aspects of this person are what they say they are. And that is mind-blowing. That's revolutionary. I think we talk about applications like that, going back to blockchains, like, we're at the beginning of the beginning of the beginning. And I hope that that's where we ultimately get to. And I'm super excited about the work we're doing at Aleo. That, of course, I'm very bullish on what we're building, but also I am very confident that ZK is part of the future. And I'm confident that the work that we're doing, will help hopefully inspire others to leverage this technology to achieve those things, to enable real-world applications.
For sure, man. Like, my most, like, provocative, like, so, people ask, like, okay, well, fine, like, if we believe in blockchain, like, what's the killer app? Like, what's going to change? And, like, honestly, like, you go to someone like A16Z and they talk about, like, all of this just, like, crazy stuff, and, like, particularly crazy stuff that they can capitalize on, or someone can capitalize on. But, like, really, like, between true believers right here, like, the actual killer app that I think that crypto, but, like, maybe specifically Ethereum is gonna be, is, like, passwords, man. Like, passwords don't work. And, like, look at the way that I need to prove to, like, a bank or to an employer or to, like, literally anyone that touches money that I'm a US citizen, is to give them my social security number. And that is the reason why mine and yours and everyone's social security number is available for purchase for, like, $5 for, like, 30 billion of them. And so, like, yeah, man, I'm with you that, like, we're in the short term. That's how humans live. Like, we need to be thinking about VCs and incentives and, like, generating bags and, like, all this stuff for sure. But
and to be clear, like, I mean, it's amazing that, ZK has gone, in the span of 10 years, it's advanced 50 years. And the reason is that is naked greed, right? People want to make money on crypto protocols like Aleo, right? Like, investors who give us money. And like, I mean, of course, like, we have many investors who obviously care about the long-term vision too. But, like, look, the reality is, like, the money that's coming into the space is absolutely going to ultimately enable all these cool things. And so it is, I just like your call out that, even though it's like short-term, long-term, both can be important. It's possible for two things to be true at once, right? And so I very much agree with you there.
No, and you're right. I was painting with too broad a brush, or shooting with shotgun shells when I shouldn't have been, because, like, yeah, man, like, I believe in some VCs, and I believe in, like, some projects like Aleo that are trying to transform things. I just, like, this industry's tough, right? Because, like, for every Aleo, there's, like, 45 pump.fun coins. There's 2 Terras. There's like, there's Sam Bankman-Fried running around. And so, like, it's hard not to be, like, really skeptical and nihilistic about the capitalism side of this. But I appreciate the pushback, because you're totally right. Like, we are not moving forward without that energy.
It's the best and worst part of the space. It's the marriage of the internet and money. And, like, that enables powerful things that most people haven't even been able to imagine up to this point. And it also attracts all of the scammers that humanity has ever produced. And they're in the same place, right? That both are true. And, it's unfortunate sometimes to have to live with that. But I do think, going back to maybe the beginning of this conversation, like, I remember when I first found out about Bitcoin, when Ethereum first launched. I mean, even though, in the interim, we've had SBF, we've had Terra, and all these bad things. I mean, just... honestly, it's amazing the number of people that use USDC every day, even if it's not for, like, salaries. Like, people do use it. I mean, banks now, like BlackRock has a Bitcoin fund. Like it's crazy. And even like, and like ease of use for all these things, like what products like Uniswap have enabled, NFTs, which I think kind of went high and then died, but like actually it's like still a lot of use cases for marketing. I mean, like compared to 10 years ago, the space is light years beyond what it is. And 10 years from now, I think we're going to marvel at what we collectively have been able to do. And I can't wait. I think it's going to be really cool.
Man, we need to close this off right now so I can immediately go to our calendars to schedule the follow-up podcast episode. So, man, before I let you go, first let me say thank you. I'll say it, like definitely top 5, maybe top 1 episode. I think it was just like so enlightening and interesting and awesome. So thank you so much for your time and like your energy and like your contributions to this space.
Thank you very much for saying that. Thank you very much for having me on and letting me gush about, all of this that I'm very passionate about. And thank you for hosting the show and for informing the wider world of why this technology is important.
Oh, well, I appreciate it. And before I let you go, if anyone listening is interested in finding you, finding Aleo, or if they've been inspired to like really think about what does it mean to be building in blockchain ZK and how to get started, where would you point them towards?
Yeah, sure. So I think, at the highest level, I'll give a shout out to our mutual friend who you mentioned, Anna Rose. She has a great show called the ZK Podcast, and from there also there's a bunch of stuff that she publishes through ZK Study Club, etc. Those are great resources for people just kind of looking in to learn more about ZK. I think with regard to Aleo, so natural starting point is our website, aleo.org. If you're a developer, also you can go to our GitHub organization, AleoNet. That's the Aleo Network Foundation's organization on GitHub. We have 2 repositories there, SnarkVM and SnarkOS. So you can actually get your hands dirty, run a node. You can check out Leo, which is our language we talked about, leo-lang.org. That's where you can kind of understand, and learn a little bit about what it's like to write a program in ZK using our domain-specific language. So that's that one. And then lastly, I would say for anybody who's really hardcore interested in the proving as a service kind of, future of hardware, we didn't get time to talk about this, but I run this org called Zprise, which is all about basically accelerating zero-knowledge cryptography. And we publish all of the results, all the results are open sourced. And we've had some incredible breakthroughs over the past couple of years. So that has its own, we have zprise.io. And then also, if you go to our GitHub organization, I think it's Zprise. I think it's just Zprise. Well, I'll give you the note. And you can put it in the link. But anyway, Zprise is its own org, and all the open source results there are published. And we just published the 2023 submissions that are represent some real breakthroughs in ZK proving times and efficiency. So. For those who are really wonky, you'll have to accelerate GPU, implementations of algorithms and GPUs. Have at it. That's it. Yeah. So, and I guess lastly for me, I'm on Twitter, apruden08. At some point, I'll probably get on Farcaster and other places, but for now, apruden08 on Twitter is the place to find me.
Awesome, man. Well, you already had me before, but fine, we'll do it again. So we've got the Aleo follow-up conversation, and now we have a Zprise conversation that we need to have.
Cool. All right. Well, sounds like we'll be chatting again soon, Rex. I'm looking forward to it.
For sure, man. Thank you so much, and have a good rest of your day.
Thanks.